All right, so let's review this optimization question. So we have a closed cylindrical can with a radius r and height h, and has a volume of 24 pi. Okay. Part A says express h in terms of r. Okay. So express h in terms of r. So first of all, let's use this information that we have. So we know volume, right? So they're giving us the volume. So that's kind of a hint that we should be using the volume formula. So the volume of a cylinder we know is the area of the base, which is a circle, pi r squared, times the height. So pi r squared times the height. So this is the formula for the volume of a cylinder. Now they tell us the volume is 24 pi, and they want us to express h in terms of r. All right, so get the h by itself. So we would divide by pi r squared, divide by pi r squared. So that's going to give us h is equal to 24 over r squared. Okay, so h is equal to 24 over r squared. So that's part A. Let's take a look at part B. The material for the base and top of the can costs 15 cents per centimeter squared, and the material for the curved side costs 10 cents per centimeter squared. The total cost of the material in cents is C, okay? And they want us to show that C is equal to 30 pi r squared plus 480, all right, pi divided by r, okay? So first of all, let me erase this real quick so I can get some room. So I'll do part B right here. So part B, so they're saying that the cost, right? So the cost is equal to, now the cost of the top and the bottom, they're saying is 15 cents, all right? So we're going to have 15. Now the top and the bottom are circles. So basically we have 2 times pi r squared. Okay, because basically what we're doing is we're finding the surface area, right? The surface area of the cylinder, right? So the bottom is a circle, the top is a circle, so that's 2 times pi r squared, because the area of a circle is pi r squared. And then we have plus, now we need the middle part. Now it says the curved side costs 10 cents, right? So this is going to be 10 cents, right, times this curved part. Now remember the curved part, if you unfold it, it's basically like a rectangle. So one side would be the circumference, so we would get 2 pi r times the height, right? Times the height. So if you unfold this cylinder, basically you would get a rectangle where this side here, all right, this would be 2 pi r, which is the circumference of the circle, and then this side here would be this height right here, right? So that's how I end up with 2 pi r times h, okay? So if we multiply this, we're going to end up with C is equal to 30 pi r squared plus 20 pi r h, right? Now you notice in this show, though, there's no h in here. So that's why they had you solve for h in part A, because we're going to substitute the h into here and further simplify it. So we're going to end up with 20 pi r. Now h is 24 over r squared. So now if you simplify everything, you're going to get 30 pi r squared plus, so this r simplifies with one of these, multiply that, you'll get 480 pi over r, which is what we're trying to show. Okay? Then the last part, it says, given that there is a minimum value for C, find this minimum value in terms of pi, okay? So basically, in order to minimize this, right? Because anytime they want you to, find the minimum of something or find the maximum, it's an optimization problem. So what we're going to do next is we're going to take the derivative, right? So anytime you need to minimize or maximize, once you have this equation, right? Once you have this equation, what you want to do is you want to take the derivative of it, then set it equal to 0. Okay? Something really important though. Let's say you were not able to do part B and you couldn't figure out how they got this. then that's fine, right? Just use this equation and you can still do part C even if you weren't able to figure out part B. Okay, so keep that in mind. So I need to take the derivative of the cost function. So the derivative of C is going to equal, now 30 pi, those are constants. So I'm basically just doing a power rule here. So I have 2 times 30 pi r, all right, plus, now this, the 480 pi, I'm going to move this r to the top, write it as r to the negative 1. So when I power rule this will basically become like a negative 480 pi r to the negative 2 power. Okay, so that means my derivative for the cost is going to be 60 pi r minus 480 pi divided by r squared. So once you have the derivative, right, of whatever function that you found previously, now you're going to set it equal to 0. So set the derivative equal to 0. So this is going to equal 0. I have 60 pi r minus 480 pi over r squared. So what I'm going to do now is I'm going to multiply everything by r squared to get rid of that denominator, right? So I'm going to get 0 is equal to 60 pi r cubed, r squared will divide out, minus 480 pi. Now I need to solve for r, so I'll add 480 to the other side, so I get 480 pi is equal to 60 pi r cubed divided by 60 pi divided by 60 pi. So I'm going to end up with r to the third is equal to 8. So that means that r is going to equal 2. Okay. Now, once you know what r is, remember they actually asked you to find out the question. Let's go back. The question actually asked us find the actual minimum value of c. So once you know what r is, you want to plug that into into your cost function right here. So our cost function. So we have the cost is equal to 30 pi, r is 2, 2 squared is 4, plus 480 pi divided by 2. So c is going to equal, we get 120 pi plus 240 pi. So it looks like c will equal 360 pi. And they wanted our value for the minimum value in terms of pi. So you can just keep the pi in the equation and you don't need to give a decimal. Okay?